Okay, this is the second video in a series on double replacement reactions, which are called precipitation reactions. And what I thought we would do here is just practice three of them. In the first one, we're going to look at the reaction of lead nitrate. This technically this would be lead 2 nitrate. And this is going to be in a reaction with sodium iodide, and so I'm writing the balanced molecular equation for this, and the product is going to be lead iodide, written this way, lead 2 iodide, and it's a solid. And we're also going to produce sodium nitrate, which is aqueous, remains in solution. All right, so really quickly, let's just review the basic definition of a precipitation reaction. It involves the combination of two ionic solutions. We know these are solutions because of the aqueous designation, which means dissolved in water. All right, so we have the combination of two ionic solutions, and one of the products is a solid, which we see here for the lead iodide, and the other product is usually also, well, not usually, it's going to be an ionic solution. Now, the three reactions that I'm picking on this morning, I chose specifically because the viewers may find themselves in all kinds of different chemistry classes. But if you're taking this class from an analytical chemist at the university level or in a high school, more than likely you're going to have to know the solubility rules, and you will be working with these three particular reactions in the laboratory. So what makes this one unique is that iodide is considered a qualitative test for the presence of lead, and the precipitate that forms is actually bright yellow. I'm gonna label that. This solid that forms here is usually, well, not usually, it is bright yellow or even neon yellow. I mean, it's a very, very obvious solid that forms that's unique by comparison to others. All right, now, if you know your solubility rules well enough, and you have enough experience, if you're asked to write the net ionic equation, it's pretty easy to do from the point of view if you recognize the solid or not. So in other words, the net ionic equation is only going to involve the ions that produce the solid. So you can write the net ionic equation for this directly without having to go through and writing the complete ionic. But in the interest of practice for all the viewers, I think what we're going to do is go ahead and write the complete ionic. And the complete ionic equation entails showing all of the ions that are completely ionized in solution, and writing the only compound where the ions are not separated being the solid and everything else is separated. So if we write that equation with this in mind, this is what we're going to have. Keep in mind you got to pay attention to your stoichiometry here, meaning that you've got to show the right numbers and types of atoms, which I'm making a mistake of right away out of the gate here as I'm telling the viewer what to do. So this is plus, yeah, and then we need two I minuses here. And then on this side of the equation, we represent the solid the way it is in reality together, and then we're going to have sodium nitrate is separated into its ions like this. Okay, now you look on both sides of the arrow and we cancel the things that appear on both sides. These are called the spectator ions. So we're getting rid of the spectator ions. And then what you're left with is the net ionic equation that only involves the ions that form the solid product. So that would be this equation here, and to emphasize, this is going to be a very bright yellow precipitate, bright yellow solid precipitate. All right, very recognizable. You can't miss it. All right. Now the next example is. Again, I'm picking on these because these are the ones that you're most likely to find yourselves doing in a laboratory. So that's going to be the reaction between silver nitrate and some kind of a chloride. Keep things simple. I'll just use a potassium chloride here. All right. Again, don't forget the hallmark of these reactions, meaning that we have two ionic solutions that are being mixed together, and one of the products is going to be a solid, and the other product will be an ionic solution. Right now, this particular silver, when it combines with chloride, makes a very apparent white PPT or precipitate. Very apparent and completely recognizable and different than the yellow precipitate that lead forms with iodide. So again, this is a feature that allows you to qualitatively identify the presence of silver that is in a solution. And for this one, we're going to practice the trick that I suggested for the lead. In other words, if we know what the solid is, then we can do the net ionic equation directly, because the net ionic equation only involves the ions that are involved in forming the solid. So this would be the net ionic equation. And to emphasize again, this is a very obvious, can't miss it, in your face, white precipitate. Okay, and then for the last example, what I want to look at, and I used an example in the first video in this area with a barium compound. And I want to come back to the barium because this is also used in laboratories quite often. The barium and the sulfate interchangeably to qualitatively identify one or the other. So for this one, what I wanted to do is come back and look at another barium sulfate precipitation example. All right. Now in this one, we're reacting barium nitrate with aluminum sulfate. All right, and the reason I wanted to do this example again is because in the first video I used, in the precipitation reaction, I used barium chloride, and that in an analytical lab is not going to be your best choice. You're going to be utilizing, if you're looking for a sulfate, all right, you're going to be using barium nitrate because all nitrates are soluble. All right, all nitrates are soluble. And what that means is that it's not going to the nitrate's not going to cross react with anything. And if you're using barium chloride and you're trying to identify sulfate, the thing that you would need to remember is that the chloride can possibly interact with something like silver, all right, which is up here in this example. So barium nitrate in an analytical lab is going to be the compound of choice to use for a test like this. All right. So again, what we're going to end up with here is going to be the barium sulfate, and that's a solid. And this is this is a brilliant white PPT. I'll just bring an arrow here. This is a brilliant white precipitate. And then we're also going to form an aluminum nitrate aqueous or ionic solution. Okay. And then let me make sure to get this thing balanced. I think we need a 3 here. And that should take care of business. All right. Now, again, the trick to the ionic equation without having to write out the whole complete is to look at the solid that forms and understand that in that solid are the ions that are utilized for the net ionic equation. So I'm going to just go ahead and write it here. And if the viewer's wondering what happened to the 3's here, for practice, if you carry this out on your own, what you'll end up seeing is that, maybe I can just quickly do it here. You're going to have a 3 here, a 3 here, and a 3 here. And these, of course, are going to cancel out. Okay? And what you have in the end then is just the barium plus the sulfate to make the barium sulfate solid, which again is a white PPT, or a white precipitate, excuse me. I keep using my acronyms for my own class. So this is a brilliant white precipitate. Can't miss it, in your face, brilliant white.